All right, so triangle angle proof. So let's get started. So we're going to prove the triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. That is what we're going to prove. An auxiliary line can be added to a diagram to give a given diagram to be used in a proof. So this here is an auxiliary line. Do you see this line here? So if you were just given triangle ABC and you needed extra lines, you are allowed to draw a third line in. Does that make sense? Has everybody got that? Okay, so we're going to start our proof. We are given that is a triangle, and that's it, and we are going to prove that they add to 180. So we always start with our given. Okay, so we are going to we're going to have our auxiliary line drawn in, but you'll notice that it is already like parallel. So line BD is drawn through point B parallel to AC. So you can draw any line in that you want that is parallel to another line. This is just by the parallel postulate. Because every line has another line that is parallel to it, right? You can find another parallel line if you want it to. So that's something new to you guys. You are allowed to add lines into proofs. What?
Calculator today?
You may.
Tomorrow?
Right now?
My mom's yeah, your geometry teacher.
No, I do like you.
I was like, what? She's like, are we about to have zero math this year? And I was like, oh.
I do like you. That is not the issue.
She's like, yeah.
That is not what I said. I just want you to get your work done.
I feel like we're about to put any teacher's emails usually automatically.
No.
That's not true.
She sends it to everyone with a D or F.
All right.
Okay, Lindsay, thank you.
So we're going to use angle addition now. Angle 4 plus angle 2. I guess I got to draw another line in here, or another letter in here. Let's put a letter over here. We'll call that E. So angle 4 plus angle 2 plus angle 5 equals angle EBD. Do you guys remember the angle addition postulate you guys learned last quarter? So any angles that add to it. So angle, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals the measure of angle EBD. And that's the angle addition postulate. Parts equal whole. So think about a pie. If you were thinking about a pie, these would be 3 pieces of pie, right? Do you see that? 3 pieces of pie here. And this is like half a pie. Those 3 pieces of pie equal half the pie, Logan. That's what I'm trying to say there. Stop shaking your head at me. Do you understand what I'm saying now or no?
Yeah.
Are you sure?
Well, I don't think that's
What do you guys know about angle EBD? What is it? It's a straight angle, isn't it? So it is a straight angle. So angle ABD is a straight line, which means that, so angle EBD, sorry.
Oh no.
So angle EBD is a straight line. That's just the definition of a straight angle. What do you know about a straight angle? How many degrees is a straight angle? How many degrees is a straight angle, Carmichael? 180. So that means the measure of angle EBD equals 180 degrees, because that's the definition of a straight angle still. Straight lines, but straight angle just means that you're using 3 letters. So like instead of the angle being like bent, we just like flattened it out. So it's kind of like this here. What? Yes, I remember everything. So it's kind of like this here. This, Lindsay, this is an angle, right?
Yeah, I
So a straight angle is when you have it straight.
I know. I was like,
No, I was just
Yes.
playing that.
All right. Which means that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals how many degrees? What is it? 180. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. What is the reason for that? What reason is that? No. What'd you say? You're substituting in. You are not. No. And I have no more space, so I'm going to come over here now.
not almost done with this proof.
Close, but not all the way close.
Joking, I have no room.
You can...
Well, just move over like she is.
Diagonal.
Um, well, they are. All right, 7. Okay, these 2 lines are parallel. What do you know about angle 4 and angle 1? What kind of angles are angle 4 and angle 1? What kind of angles are angle 4 and angle 1? Think back to last unit. This line is extended out. Those are your parallel lines. What kind of angles are those? What do you know about alternate interior angles if their lines are parallel? So angle 4 is congruent to angle 1 because of alternate interior angles. What other 2 are alternate interior angles? We'll do it in the same step. What other 2 are alternate interior angles? What is 5 alternate interior to? Do you see that 5 and 3 are on opposite sides of the transversal in between the lines? So I'm going to put that all in the same step. So, and angle 5 is congruent to angle 3 because they are alternate interior angles. So then we have to use the definition of congruence. So the measure of angle 4 equals the measure of angle 1. And the measure of angle 5 equals the measure of angle 3 by the definition of congruence. I'm going to say definition of congruent angles. Then what can we do to say that they add up to 180? We know 4 is the same thing as 1. So can we replace 4 and 1? And we know 5 is the same thing as 3. So can we replace 5 and 3? So then do we have 1 plus 2 plus 3 equals 180 like it wants us to say there? Just sure. Okay, we'll walk through this proof again.
No.
Yes.
Yes, that is supposed to be there. It's supposed to equal 180.
I am going to talk through this whole entire proof again.
Please
Oh
don't.
my god, I said sure meaning yes.
I don't even think we have.
Do you want
We
me
do,
to
don't
say-
worry.
Yes, that is the proper way to do it.
All right, so if you're looking at this proof, please pay attention. Please pay attention. You're given that we have a triangle here and we want to prove that these angles add to 180. So we started by drawing an auxiliary line through point B. So so that it was parallel to the base of the triangle, right? That allowed us to use alternate interior angles later on in the proof. That's kind of why we did that. It also allowed us to get an equation where something was adding to 180, because we needed that for our proof, right? So that's part of the reason why we did that. Don't even. So, we know that these three angles added together form this straight angle here, or the line that's there. We know a line is 180 degrees. So we had that, those add to that angle by angle addition, that it's a straight line, because that's the definition of a straight angle, which means it equals 180 degrees. So we know EBD, which is right here, is the same as 180. That's substitution. When two things are the same, we replace them. So we had our auxiliary line drawn in for that reason, and here's our second reason. So we have a transversal cutting right here through our two parallel lines. 1 and 4 are sandwiched in between those two lines, which means they're interior angles. But they're on different sides of the transversal, which makes them alternate. That's where that alternate interior angles theorem comes in that we learned last unit. And that's the same thing as what's happening with these, so that's why they're congruent. Another reason why we drew that auxiliary line in. We can't substitute until we have them switch from congruence to equals, so that's why we used the definition of congruence, or definition of congruent angles. And then we said, well, if 4 is the same thing as 1, we can replace the 4 with 1 here. And if 3 is the same thing as 5, we can replace the 5 with 3 here, getting us to that adding to 180. So hopefully that makes a little bit more sense to you guys. Unless it already did, but I think some of you guys were lying to me. All right. Next one. Exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Some of them are fill in the blank too. Quote from one of you, I don't think we have enough time to go over that proof again. That was one of you saying that. If you don't understand, I'm going to go over it. I don't care about the time. Oh, you guys are so funny. I'd rather not understand it. It's okay, guys. That's where you guys are at right now. So ABC with exterior angle.
I feel
Just
like
get it
Freddie
done.
out of all my teachers, like, gets teenagers with us. Like,
I do understand you guys. I don't know why, but I do. This is why I don't teach young children, because I don't even know what to say about them half the time. My own child. Okay, so we need to prove that this angle A plus this angle B is equal to the exterior angle BCD. Why did they use 3 letters for that one, but only 2 for the other 2? We talked about this on Monday. Who remembers why they had to do that? Why do you have to use 3 letters versus 1 letter in some situation?
because it's the angle and it's like the vertex, maybe?
You wrote it wrong. Because we tried.
What?
Okay, I think I'm okay.
I can't see.
Why would they do that, Katie?
Because there's other, the letters are the same, so you can't just say.
I got to make sure I'm not in Casey's way. Yes. So B and A only have 1 angle there, but angle C, if we were to say this, I would have no clue what angle you're referring to. There's an angle here, there's an angle here, and there's also the straight angle. So that's why I have to know 3. All right. We know that by the angle sum theorem, by the triangle angle sum theorem, which we just proved on this page here, the triangle sum theorem, that if you add all the angles of a triangle, it adds to what? Right? The angle A plus angle B plus angle BCA equals 180, because it's a triangle. So that's the triangle sum theorem. We just proved that on the previous page. So the measure of angle A plus the measure of angle B plus the measure of angle BCA equals, I'm going over here and I don't even care, 180 degrees, because the triangle sum theorem. That is the theorem we literally just proved on the previous page with that auxiliary line. So if you need me to go over it again, I can go back. But I'm going to assume you guys really don't want me to. So.
I don't think I have time.
What do you know about these two angles? What do they form? Straight line, which we call a, when there's two of them, we call it a linear pair. So we can say the measure of angle BCA plus the measure of angle BCD equals 180. Because of the linear pair postulate. Harmony's like, why did I come back today of all days? You should have come back Monday. Monday's lesson was fantastic.
Honestly, that was probably the best lesson of the year.
I was going to say, so easy.
I don't remember, but
What did we learn?
Corresponding parts of congruent triangles are congruent. CPCTC.
Remember this?
Saying that the sides are congruent and the angles are congruent on two.
I don't remember that.
It was really easy.
It's that Tuesday in between. We can't even remember what happened Monday. They both equal 180. They both equal 180. If two things equal the same thing, aren't these two parts the same? So can't we set these two things equal to each other? Okay, so we have the measure of angle A plus the measure of angle B plus the measure of angle BCA equals the measure of angle BCA plus the measure of angle BCD. And that is just by substitution. If two things are the same, you can replace them. Sorry that I'm continue to go over my line. I'm here after school today if anybody wants to come see me to get caught up on their missing work or want to retake something. I'm here. What?
I told my mom told me to stay today, but I actually can't. You know why? It's the first meeting of the winter show. And I'm in the winter show.
You made the winter show? Yay. I was afraid to ask. It's always a terrifying question to ask when people try out for sports. Like, do I ask? Do I not ask? You know what I mean? Like, it's just so terrifying. It's kind of like when two people are dating, too, and you're like, do I ask about their other person or not? Because if they're not dating anymore, this is super awkward. It's that same situation. No, like my students, when I know like two of my students are dating.
Greg got a lead role in the show. So, give that boy a high five.
What are you doing? Hey, but you're still in it.
I know, I had a lead role last show, so it's fine.
It's fine, you're awesome.
Sometimes you just gotta do it, and then also you can-
All right. What do you guys notice is the same on both sides? What do you guys notice is the same on both sides? So what can we do with BCA, Abby? We can subtract by BCA on both sides, which will cancel that out, which will give us measure of angle BA plus the measure of angle B equals the measure of angle BCD. Is that what we want our proof statement to be? So we will be done once we do that. So we just subtract it on both sides. I'm not even going to show it. So I'm going to have measure of angle A plus the measure of angle B equals the measure of angle BCD by subtraction. This one's a little bit easier to understand, I feel like, than that auxiliary line being drawn in.
The underworld.
Huh?
Is that the sound of it?
No, I think that the preschool plays in the commons during this hour.
Yeah, I think it's like murder time they did.
Yeah.
Here's a screen.
No, kids just think it's funny to scream at
Wait,
anything.
one of those little kids was dressed up as Mario for Halloween. It was so cute.
Kids are adorable.
I was like,
What? No, that's terrible. Never ask me that again. You're fine. All right, we have 2 more proofs. Any questions so far? Austin's like, get me out of here.
Didn't you throw like a thing for your kid this morning?
Yeah, I went to Muffins for Mom with my child this morning.
Didn't bring me any muffins?
Well, it's technically donuts, but you know,
Calling muffins.
yes, I can. I think because it's cheaper to buy a whole bunch of donuts than muffins.
Do you just have to go eat donuts and then
I sit and eat breakfast with my daughter. I never get to do that with her.
It's so weird that you like you just go do you go to her school?
Yeah, I went to her school.
What time did the school
She goes to Zion, which is a private school. So in the church basement, they had like muffins for everyone. So
The church basement? That sounds a little weird.
why is that creepy? Oh my gosh.
Church basements are just kind of weird.
But anyways, they have like a before care starting at 7. They start school at 8. But she goes to before care every day because we both work. Are you ready? Whoever asked me to go back? Okay. So, we have our 2-column proof that we're going to write for this one. No.
Keep on calling
the what?
them column proofs.
That's because there are like flow proofs, which is like,
Like the person works at
no, not like progressive flow. But it's more of like, I'll show you some of those when we get to the triangle proofs. It's more of like a mapping. So you know, like, have you ever had
No.
like a diagram drawn and then you draw like an arrow to something because it means that? Have any of you ever used Prezi before instead of PowerPoint? It's kind of like something like that. I don't like Prezi either, so.
It's weird.
It's too much going on for my brain to handle, so that's why I don't like it. All right. Angle STU is congruent to angle VWU. And so we're going to mark those. We have that marked here and here, okay? And then we also have measure of angle STU is 66. And the measure of angle TUS is 44.
Well,
They're having a lot of fun down there.
or maybe
a lot of fun being murdered.
I guess I have to shut the door because you guys can't handle children screaming. They're not. Kids like to scream just to scream.
Don't know.
All right. Stop talking. All right. We need to prove that the measure of angle V,
I saw her and she told me I was going to do really good on the proof, so now I have to do good.
there you go. So the measure of angle V has to be 70 degrees. So we have to start here. What kind of angle is SUT and VUW? Lindsay, it's your favorite type of angle. SUT and VUW. Good. So we know that the measure, so angle SUT is congruent to angle VUW by vertical angles. So that's the vertical angle theorem. And then I switch that to equals, so a measure of SUT equals the measure of VUW by definition of congruent angles.
Hi, this is for Morgan James.
Thank you.
class, you kidding me?
Okay, stop talking. Which means that the measure of angle VUW is 44 degrees, because SUT, which is the same thing as TUS, right? Do you see how TUS
Yes.
and SUT are the same? So that means that the measure of angle VUW equals 44 degrees by substitution. What is the measure of VUW? Or how do they have it? VWU. What does that measure? What is it, Devin? 66, because it's the same as STU, right? Isn't that what we have here? So we're going to also say that the measure of angle STU equals the measure of VWU. Stop talking. That's definition of congruence. And since those two are the same, we can say that the measure of angle VWU equals 66 degrees. And that's by substitution. Okay, so before we keep moving on, does anybody have questions on what has happened so far up here? Because there's a lot going on. So I'm going to pause before we keep moving on. We are not done with this proof. Don't worry, guys. So we know STU is congruent to VWU. That's these two angles here. So before you can use substitution, you have to switch it to equals. So that's what I did down here in step 5. So I used the given information to switch this to equals and use definition of congruent angles. I then said, well, if these two things are the same and STU is 66, that means that VWU also has to be 66. We also looked at the fact that there are vertical angles here. We said SUT and VUW are vertical angles, which means they are congruent. Again, before we can do substitution, we have to switch it to equals. So we did that. And then we said, well, if SUT, or TUS, same thing, is 44 degrees, then that has to be 44 degrees. Now, we are trying to prove that angle V is 70 degrees. What do you guys see here? What shape is formed here? A triangle. And what do we know about the triangle sum theorem? So we're going to say that those add to 180. So we're going to say the measure of angle V, but I guess I'll just use the angle V, yes, plus the measure of angle VUW plus the measure of angle VWU equals 180 by the triangle sum theorem. I'm going to have to go over to the other side again. Yeah.
The step number 5, wouldn't that be still?
It comes from step 1.
Yeah,
Because they're congruent up here,
yeah.
but we can't substitute until they're equals.
And then at the end, would you put it back to congruent? That's what, oh, no, you're not.
You're not proving that. If you were proving that, you would, but we're not. Not right now, I'm in the middle of this. What do we know VUW is the measure? How much is VUW? What is VUW's measure? Nope. VUW is 44, and VWU is, so we're going to use substitution there now and plug those in. So the measure of angle V plus VUW, which is 44, plus 66 equals 180. Which is substitution. Then we can combine like terms. If you combine like terms on the same side of the equation, what is that? If you combine like terms on the same side of the equation, what is that? What is the reason when you combine like terms? It's not combine like terms. What do you use? Substitution, because we're saying 66 plus 44 is the same thing as 110. So that's substitution, and then we can use the subtraction property. So then we can use the subtraction property. Can you guys see this if I do that?
Yeah.
The measure of angle V, can you see that there?
Yes.
Equals 70 by subtraction. All right. Last example.
Hold on.
I'm not changing it. Don't worry. Yeah, quickly. Does this one make sense to you guys, what we did through the steps, or does somebody need to go through it again? Because I can, before we do the last one. Do you understand it, Ian? Could you mimic this proof? If you took your notes out, actually, when you did your homework? How many of you actually used your notes on your homework? Just wondering. Okay, that's a lot more than I thought. Okay, Devin did this. I think that's probably more realistic for some of you, but yes.
Just depends on what it is.
Good. I feel like some people, like, they take notes and they're like, never going to look at these again, and they just go to die in their backpack. Yeah. Mm-hmm.
In the bike.
Yes. Sometimes I wonder. Maybe because one day I just hope that it will click for you that you should be doing that. So we are going to prove that the measure of angle 1 is 56 degrees. We are going to prove that the measure of angle 1 is 56 degrees. So we need to find what x is first. So let's write down our given, and then we'll have to figure out what x is first. So we have triangle ABC with exterior angle BCD. Okay, what can we do to figure out what x is? What can we do to figure out what x is? There's going to be a little bit of an algebraic proof inside of this. What can we do? Katie?
3x plus 16 equals 52 plus 2x.
And that's the exterior angle theorem, right? So before we do that, we first have to do the blank theorem. So we first have to say CBA plus BAC equals BCD. So you first have to write it out that way. So measure of angle CBA plus the measure of angle BAC equals the measure of angle BCD. And that is just the exterior angle theorem. And then by substitution, we're going to replace it with what Katie said. So 52 plus 2x equals 3x plus 16. That is just by substitution. So now we're going to kind of do an algebraic proof here. What would you do first to get x by itself? Tell me what you would do first to solve for x. Cameron, what would you do first to solve for x? So subtraction property of equality. So if you subtract 2x on both sides, that would just be x there, plus 16. And that's the subtraction property of equality. Very good. Abby, what would you do now to get x alone?
Subtract 16.
Okay, if I subtract 16 on both sides, that is, I can't think, 50, 42, 40, 36. So that is subtraction as well. Okay, so now that we know what x is, we can kind of figure out what angle 1 is here, or what angle BCD is, right? So we know the measure of angle BCD equals 3x plus 16. That's from the diagram. You're adding the same thing on both sides, so that's just the addition property. What do we know that x is? What is x? What is x? So we can do 3 times 36 plus 16 by using substitution. And then what's 3 times 36 plus 16? We can just go straight there. Can somebody do 3 times 36 plus 16 in their calculators? Plus 16. 124? That is just substitution again because you're just combining like terms. Okay, so far we have these two angles equal the exterior angle by the exterior angle theorem. We know that 52 and 2x and 3x plus 16 are those things. We then did subtraction of 2x on both sides, subtraction of 16 on both sides to get x is 36. We then said BCD is the same thing as 3x plus 16 because it's in the diagram. And we said x is the same thing as 36, so we substituted and got that. Do you guys see the linear pair here? BCD and BCA are a linear pair. So we're going to say the measure of angle, BCD, plus the measure of angle, BCA, equals 180 degrees because of a linear pair. But I'm actually going to call that angle 1. Which one is angle 1? BCA?
What do you want me to do?
I'll grab it in a second. And we know BCD is the same thing as what? What is BCD the same thing as? 124. That's substitution. So we subtract that on both sides. And that's 56 degrees by subtraction. All right, that just took